thing, this is something extra information that we can give in the header. So this is 40 bytes, and we have two categories are there: single byte and multiple byte. We have already discussed in the IP packet as well. End of list. This is value 0. No operation value is 1, and then we have some more information in the option fields. So this already we have discussed this part. Then maximum segment size is used to make an agreement that what is the size of the segment. So when the two parties start communicating, they send the sync packet. They send the sync packet that I want to communicate. As a reply, it will send sync plus acknowledgement that okay, we can make a connection. Along with this, it will send MSS information in the header. Now this information is to tell what is the size of segment. So let's say if it is said size is 600 bytes, for example. So this is the size of the segment which is actually agreed by both the parties. If this is not mentioned, then default value is 536. Again, I am repeating, don't confuse this with the window size. Window size is a different thing. Window size means this size may be 6000 bytes. Okay, and this will inform the size by the concept of RWND. It will say my window size is 6000. That means I can accommodate this much of data. But what is the meaning of this? The meaning of this is based on this RWND, the sender side will again maintain its this much buffer. But this value tells us that when the application layer provides 600 bytes of data, you can make one segment and then deliver. It is required because the receiver machine is aware about the MTU status. MTU status will guide the size of the segment. So it is aware about the MTU status, and accordingly it will informing that don't send me the larger packets, otherwise it needs to be fragmented. To avoid fragmentation, we use MSS concept. This is window skill factor. This is used when the receiver has a larger buffer size. We have a limit that window size is actually window is using 16 bits, so you can only announce up to 2 power 16. But if the receiver wants to announce larger size, then it is not possible because the number of bits we have only given 16. So in that case, we can use this, means the software can use this WSF field. What does it mean? It means if the receiver is having this huge amount of buffer is available at the receiver side, or you can say at the server side, but it cannot announce this this much size because the window field is only 16 bits. So it can only announce RWND maximum 2 power 16. Now how can we do this? This we can do with the help of skill factor. So if the packet contains WSF is equals to, let's say 8, that means the receiver want to announce that my window size is 2 power 16 into 2 power 8, that is 2 power 24. This is the window size. So new window size you can find out using this formula. New window size is the window size and header and multiplied by 2 power WSF. Now here you have to remember that the code is 3 and the length is 3 and the 1 byte is for the scale factor. So the total length of this particular option is 3 bytes. This you have to memorize. So if you find value is 3, this is a scale factor. If this value is 2, then it is a maximum segment size. Now we have a limitation. This can be 1 to 14. This is a limitation. We cannot have value more than 1 to 14. If you write more than 14, then it will not be accepted. So if you write 15 or 16, this may work, may not work, but up to 14 is acceptable with all the protocols. So what does it mean? It means the maximum size that the receiver can announce is 2 power 16 into 2 power 14, that is 2 power 30. So this is the maximum size that can be announced, not more than this. And this is agreed at the initial, means when the two parties start communicating, it sends a starting message request that I want to make a connection. As a reply, it will get a sync plus acknowledgement, and along with this, it will get more information, MSS plus WSF, means what is the size of the segment and what is the size of the window. Everything is there in the first phase. And then onwards, they will keep on hold this information and then use in the second phase. In any case, you cannot make your window more than 2 power 32. You know why? Because the sequence we are having 32 bits. So that means you can generate 2 power 32 sequences you can generate. Or you can say you can send only 2 power 32 bytes of data. That is something 4G data you can send. So even if you declare your window size more than this much space, it is of no use, because a sender cannot send a segment more than this size. The limit which we have chosen or fixed is 2 power 30, means the maximum window size you can declare is 2 power 30, and maximum segment size that can be delivered is 2 power 16 only, because we have 2 bytes for MSS. So the maximum segment size is this much only, and maximum window size is 2 power 30. Then the next field is timestamp. So timestamp we are doing two, means it is used for two purposes. One is to calculate the round trip time, and the other is used to do this PAWS. So round trip time is calculated. Round trip time is a time to deliver a packet and get the acknowledgement. So this time is called round trip time. Now to find the round trip time with the help of timestamp option, there are two variables used. Now these variables are used at the server side. So we use two variables. One is called, name can be anything, but this is something general name we are using is, that is called last acknowledgement. So last acknowledgement is one variable that keeps some value, and also we used TS recent here. This is for recent timestamp. So two variables are used to find the round trip time. Now these are maintained at the server side. So at the sender side there is no need to, at the client side there is no need to maintain any variable, and you can easily find out the round trip. So how they are using it? This is an example here. So these are the variables which are maintained at the receiver side. So it will maintain one value in the last acknowledgement variable, one value. Now this value is a value which is sent by the receiver that says I am expecting this acknowledgement, means there is some packet delivered already which says ACK is equals to 12,000. This is already delivered before this kind of transmission we are looking from here, but before this something is already delivered from the server side. Now this value is stored here, and there may be some value, we don't know, let's say 5,000. It does not affect, right? Now whenever the sender send any packet that bears this acknowledgement number, means that bears this sequence number, so it reaches here. So sender is sending a packet, and in the packet it will also mention the time when the packet is delivered. So this time is mentioned in millisecond. 4720 is the value in millisecond which is there in the packet. It is mentioned here, and the packet is delivered. So when the receiver gets the packet which is the matching with the sequence number which is already at the last acknowledgement, then it will take this value and write it here in this variable. When this value, the value of last acknowledgement, matches with the value of the first byte, then it will take a note of this timestamp value, that is 4720. Now if you see here, this packet is also received, but here the value is 1200 and it is not matching with this value. That's why this timestamp is not taken into consideration. Only the timestamp is taken into consideration that matches with the last acknowledgement value. Okay, so after some time, when two packets are received, it will give a cumulative acknowledgement, means acknowledgement for this packet and this packet. So it says 1220, that means I am expecting this byte. Now this is noted here. Now see, means now I will update the values when I get a packet with this much sequence number. And whatever the value is here, it is also noted in this packet and then deliver this acknowledgement. Now the moment the sender receives this packet, it will note it down at what time the packet is received and look to the value which is inside the packet. So this value minus the value which is inside the packet gives the round trip time. So this is a very simple calculation is used here. So there is no need to maintain any timers, any variables at the sender side. Only the receiver side will actually handle all this thing, and you can calculate the round trip time. The second usage of this is PAWS, that means protection against wrapped sequences numbers. Already we have discussed the concept of wrapping of sequences. Wrapping of sequences means we have like sequences, we have only 2 power 32. So once you start assigning the sequences to the bytes which are delivered in the packet, then it goes up to the last limit, 2 power 32 minus 1, and then when it is going to expire, means all the bytes are consumed, the sequences are consumed, you again repeat from 0, means the first value. This is called wrapping around of sequences. And we are using these numbers not from the 0, but it can be used from anywhere randomly. So let's say you start from 600. So you start from 600, go to this limit, and then you go back to 0, you go back here, and then this is called wrapping around of sequences. So the moment you start repeating the sequences is called wrapping around the sequences. So the question may be asked that what is the time when you wrap these sequences number? That is called wrap around time. We have discussed that there is something called LT. LT is a lifetime of the segments. So if LT is less than wrap around time, then there is a no problem, means there is no clash, everything is okay. But when LT is more than wrap around time, then we have seen that the problem may occur. There is a clashing of sequences because the packets are live. Both packets are live which are reaching to the receiver side, and then receiver has to solve this problem. So one problem means this problem can be solved by extending the range of sequence number. So we have seen, I am not solving the entire numerical, but if you remember, we discussed the example of 1 Gbps. In 1 Gbps, the wrap around time comes out to be 4 seconds, right? And the lifetime is 180 seconds. So this is the case of lifetime is more than wrap around time, and definitely it is going to clash. So the solution we are looking for, how to avoid this scenario. So if you look at the sequence, so in the sequence we have 32 bits, that means you can generate 2 power 32, right? Now if we increase the sequence number, means if I increase the sequence number by 1 bit, that means you have actually doubled the sequence range, and this wrap around time will be 8 seconds. If you simply increase to 1 bit, that is 233. So if you increase 1 more bit, it goes to 16 seconds. So that means if we increase the sequence field, mean the size of sequence field, we may avoid this kind of scenario. This scenario can be avoided. So we need to find out with this much speed, what is the sequence number should be required to avoid this condition. So with this much bandwidth, let's say 1 Gbps, so that means 1 GB of data is consumed in 1 second, or you can say in 1 second, otherwise I can write in 1 second 1 GB data is consumed, or you can say each byte is consuming 1 sequence number, you can say it consumes 10 power 9 sequences are consumed. Okay, now we want to avoid this scenario, so this is the rate of consumption. So we want to see in 180 seconds how many sequences will be required so that this condition will never occur. So this much is required, 180 into 10 power 9 sequences will be required to avoid the wrapping of sequences and clashing of sequences. So how many bits will be required? So you can say log 2 180 into 10 power 9. Okay with this? And this will give you something 42. So if I ask you what are the extra bits required, so extra bits you can say 42 minus 32. 32 is already there, and 42 is the requirement. So 10 bits are required to avoid this scenario for 1 Gbps speed. Now this is one kind of solution that can avoid. Now understand what is the problem. The problem is you are sending a packet, let's say the packet sequence number is 200, and because the bandwidth is very high, you are going to repeat the sequences. Let's say after 4 seconds you have repeat this sequence 200, and this packet is reaching somewhere at this time. Now, two packets are reaching with the same sequence number, same port number of the source, port number of destination same, sequence number are same, both are same in these two packets and both are live. So you need to resolve this kind of conflict. To resolve this conflict means we want to avoid this kind of scenario. And to avoid this kind of scenario, we are looking for how many bits we can increase in the sequence field so that this can never come. But the better solution can be achieved by using the option part. So we have seen that in the timestamp, we are doing round trip time, and we are doing something called PAWS. This is called prevention against wraparound sequences. So what is happening? We don't need to calculate all this thing. What we are doing, we are simply associating a time when the packet is delivered. So let's say first packet is delivered with sequence number 100, and we mention the time. Let's say the time is 4000 seconds. This is the value. And then after some time, you are again repeating the same sequence number because of the wraparound is happened, and the same sequence is used, but the time is now different. Let's say this time is 5500. So when these packets are reaching, let's say these are reaching here. Now this packet is having the value, this packet is having a value 4000, and this is having 5500 and 100. Both are having sequence number, but the time value is different. With the time value, you can easily find out which packet is delivered first and which packet is delivered later. Is it okay? And you can resolve. Otherwise, we cannot able to resolve these two things. Both appear same, and you need to keep in order. Otherwise, the meaning of the data will change. So by looking at this timestamp value, you can keep in order and you can avoid this kind of clashing of sequences. So this is the second use of timestamp option. Then the next field is sec. So we have two things. When I say sec stands for selective acknowledgment. This is called selective acknowledgement. So in the main header part, so we have, when we talk of header, in the main header, that is 20 bytes, we have something called acknowledgement field. This acknowledgement can only inform the sender that what byte is expected. So if it is saying 300, that means I am expecting the byte with sequence number 300. This is the meaning. But there is no information about the duplicates data received or the out of order data received. This is also required to inform, because if you inform the sender that I am getting the duplicate data, then data will not be again sent by the sender, and you can avoid the congestion. There is a possibility that the receiver is receiving some data that is out of order or some data which is again duplicate. So it is better to inform the sender, so the sender will not again send the same packet. This is done by using the sec option. So sec is having two things. One is called sec permitted and the other is called sec option. Sec permitted is only used in phase 1. It's only used in phase 1, and sec option is used in phase 2. We have two options are here. One is sec permitted and sec option. Sec permitted is used in phase 1 and this is in phase 2. The purpose of this is just to make an agreement that both the parties are interested in sharing this sec information. So how this works? So when the two parties start communicating, the sync packet is sent as a request. It will reply the sync plus acknowledgement, and in this packet there is information about the MSS, what is the segment size, what is the window scale factor, and also they will send information about sec. If there is a reply of sec, if in the phase 1 there is a reply of sec, that means both agrees on this sec part, and in phase 2 they share this sec option. They will share this kind of acknowledgement information. Otherwise, if this is missing in the reply in the first phase, then sec option will not be used in the data transfer. This can only be used when this is agreed, means if both are accepted that we will be using sec option. So understand the length of this. So the kind is 4. This is for the phase 1 sec permitted kind is 4 and kind 5 is for the sec option. So just keep in mind what is the value of kind here. Length is 2. So this is a very small packet. This is just for make an agreement. Now in the kind 5 this length is not defined. Length is depending on the data that is there in the header. How much data you are sending in the sec packet, and that is actually that defines the length. Now what is the maximum length possible? Now when you look at this, this is used in pairs. So this is used in pairs, and this is 4 byte. Means this is one pair makes 8 bytes. Okay. So how many pairs you can use? So let us try to understand. If I used, this is for one pair, and if I used 4 pairs, so what is the value? 32, and plus we need 2 bytes for this, means 1 byte for kind, 1 byte for length. So plus 2, that makes 34 bytes. Now if I make 5 pairs, means this is one pair, and if I make 5 pairs of this, it will be how much? 40 plus 2, that is 42. Now we know that option field is only 40 byte field. You cannot use 42 bytes because the maximum is 40. So it says you cannot send more than 4 information. This is not possible. Only you can send 4 information. So this is an example of sec. So we are assuming that both parties agreed, and the permitted they agreed to share the sec information. Now this is delivered. This is the packet delivered, which is in order. This is also reached to the receiver, which is out of order. Now based on this packet, you can make the information that I am looking for 2001. This is the acknowledgement. So every time you write 2 information. One is acknowledgement, what is the byte you are receiving for, and sec means if something extra you have received, means that if the receiver has received some extra, then it has to inform. Now 4001, 5001 segment received, and this received, means this is out of order is received. This is also out of order. So you can make a packet 4001 to 6001. This is something which is received, which is out of order. And then you received 8001 to 9001. This is also out of order. This also you are informing to the sender. The objective of this is, once this is informed to sender, the sender will not retransmit this packet. Even if the timer is going to expire, the sender is now aware that this is already reached to the receiver side, and don't repeat this packet, don't resend the packet. So what is the benefit of this? The benefit of this is it can reduce congestion. So this is the case of out of order. Similarly, we have a case of duplicate data. Now this is delivered, and now this packet is reaching, this is out of order, and this is also reaching again. Now why 2 times this is reaching is possible? Because maybe one packet is delivered and it is not reaching here, it may stuck somewhere here, and because the timeout got expired, you send again the same packet, and now both are reaching. So means you are having a duplicate, 2 packets are reaching at the server side. So this is also possible. So once the duplicate packet is reaching, you will be informing to the sender that this is the acknowledgement, means this is what I have received, I am expecting this, and what is the second information? This is the duplicate I have received, and this is the out of order I have received. This you have to inform. Now keep in mind, you cannot send more than 4 pair of information. Let's say you have information about the 3 duplicates, and you have 2 out of order. So what you can do, you can only send 3 duplicates plus 1 out of order. This you can send maximum. And the policy which we are following is, whenever you send this information, the duplicate comes first and then comes out of order. This is the rule. So first you send all duplicates, and then we have one more space, you can send 1 out of order, and the remaining you cannot send. When you send the next packet, then you can inform about the status. So here this is what is the size here. If you look at this figure, So if you look at this figure, we can easily see what is out of order and what is in order, what is duplicate. But the sender does not see this kind of figure is not available. Sender will only see this kind of packet. Now with this packet, how the sender will identify which part is the duplicate part and which part is out of order part. It's very easy actually. It will look through the acknowledgement field, and whatever the bytes which is before the acknowledgement, it is actually all duplicated, and whatever the bytes which is after this acknowledgement, this is all out of order. So by this information, it can identify it, and as a rule, always first write duplicate and then write out of order bytes. So this is all about the option field that we need to discuss in TCP.